Okay, nomenclature is the process of naming ionic compounds and covalent compounds. And what you do is you take common ions or just regular elements and you name them according to the compound that they form. And by being able to do this, you can put them in chemical reactions just like we had in our experiment.
Okay, in chemistry, there are compounds including ions and covalent bonds.
We are going to show you how to write out and name these compounds.
To start, we will show you how to name ions.
For example, tin fluoride, which is SnF2.
And we have our list of common ions, and this is tin with a 2+, and this is fluoride with a negative.
So when you write it out, it will look like SnF2. And here's why that works.
So basically what you do is, so tin has this -2 charge, and you take it and you swap it, and you put it right down in front of fluoride on the bottom, and you do the same thing with fluoride's negative charge, but since it's just a 1, you don't have to write it.
Yep. Ta-da!
Alright, so another example of this is copper oxide. And so whenever you do something like this, you have to change the ending of the second compound to "ide." So that just goes for everything.
And when you're writing copper oxide, what you're doing is you're putting the charge on copper in parentheses, and you only do this if the element that you're using and its charge is not in the left, the two very left columns on the periodic table. So it'd be the alkaline earth metals. You wouldn't write their charge in parentheses, but otherwise, if it's anywhere else on the periodic table, you would. So yeah. Thanks. Okay, you were reading this one. That's fine. Okay, so when you're naming covalent bonds or covalent compounds, you have to use prefixes instead of using the charges. So, for example, the prefixes are 1 mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octo, 9 nono, and 10 deca. For example,
we have phosphorus trichloride. And so you just write the first name, and then you see that chloride has a 3 charge, and so you just put the prefix for 3 in front of chloride.
We got this.
Good.
Another example of an ion is
aluminum sulfate, and we have aluminum right here and sulfate is right here.
Aluminum has a 3+ charge and sulfate has a 2 negative.
Yes.
So that it should look like Al2SO4 3. And SO4 would be in parentheses because you have to put the charge on the outside if there's already a number down here. So here's why that works and how you write it.
Alright, so again, we just take it and we swap it and we put it right down here, and then this would be in parentheses, and then do the same thing right here, and that's it.
So then you have Al2SO4 3. Ta-da! So what we did was we put hydrogen peroxide, dish soap, and dye, obviously, in this base, and right here we mixed warm water and a packet of yeast, and pretty much this experience called elephant toothpaste. So when you pour it in, it's just gonna hopefully, I don't really know how else to describe that. So yeah, here it goes. So cool. Hey, that worked.
It worked.
That's pretty cool. Our last experiment didn't really work that well, but ta-da! Hey, it's kind of sparkly. It's kind of cool.
It is.
It smells like yeast, and it's just foam. Ta-da! And it's warm. But yeah, it's pretty cool. That worked well.
It worked perfect.
Okay, so hey, aluminum.
Hey, oxide.
Do you want to bond with me?
Heck yeah, I do.
Oh my gosh, that makes me so happy. Here's my charge that you get to take. Woo!
Woo, yeah.
Oh, look, we're chemically bonded. Yay.
We're so bonded.
Kari here was aluminum 3+, and she took her 3+ charge and made it the subscript on oxide, and then
And then Maura took her 2 negative charge and she put it right here for my aluminum.
Chemical happiness.
Shazam!
Are you kidding me, Dad? Stop.
What are you planning on?
Nomenclature is the naming process of naming ionic and covalent compounds in. Damn it, Dad. Oh. Why you gotta do?
Where does this go?
Okay. Why did I get the rickety chair? Okay, another example is
Ammonium sulfate.
no. Yes.
Yeah.
Yay, right. Oh god. So yeah, it worked better than our first experiment, but this is good. It's fun. It's good fun. Great. Our hands are purple.
Oh, it's all sticky.
Can't stand on this video. Okay. Okay. I'm done. I can put that in the bloopers. Break my kitchen floor. Playing games. It's not a game. It's science.